Welcome to the Maintainable Software Podcast, where we explore the art of improving existing software with seasoned practitioners who have helped organizations overcome the problems often associated with technical debt and legacy code. I'm your host, Robbie Russell. On this episode, Lutz Hühnken, who is the head of engineering excellence at Upvest. Lutz joins us from Hamburg, Germany. Lutz Hühnken, we're so glad to have you join us on Maintainable. Welcome.
Thanks for having me, Robbie. Thanks.
So as you reflect on your experience in our industry, what do you believe are a few common characteristics of, dare I say, well-maintained software?
Well, yeah, I would say well-maintained software, first and foremost, is well-maintainable software, right? Software that is easy to maintain. So how do we make software easy to maintain? Big systems are hard to maintain, so we break them down, right? So I think one trait of maintainable software is it's small, or it's broken down properly. It has proper boundaries, right? If it's a small system, that's easy to maintain. If we have big complex systems, I am very much in favor of breaking them down in modules or bounded contexts as well, with clear boundaries, clear responsibilities. I think that's a very important part. But I have more. So that's one aspect. I think then the code itself, it needs to be simple in a way. Okay, simple, maybe it means different things to different people. So one thing I find hard to maintain that I don't like in code is if there's this sense of magic. If you're using frameworks maybe or features that apparently magically do things, but then when you kind of do something out of the ordinary or you have to customize very much, it gets very hard. Or if these things change or you don't really understand how they work. So examples of this would be one thing. Again, I guess this is very personal or very subjective. One example for me would be object relational mapping. Right, I've done a lot of work in the sort of Java space with Hibernate, and you can use this in a way that it generates a lot of stuff for you, that it does a lot of stuff for you, and you never have to write a single line of SQL. And I think that's just bad. It's just you need to understand your data model. I want developers to write SQL. And of course, this is still an abstraction, right? I'm not saying you always have to go down to the sort of very bottom of things and understand all the sort of the binary code running on your processor maybe. But SQL that's a good abstraction. That makes us think about things that are physically pages in memory or files on the disk in terms of sets and relations and so on. That's nice. But then having an object graph and mapping it to that, no, that's not really abstracting, right? That doesn't allow us to reason about things on a certain high level. It's just magic, right? It just does one thing, or it appears to be one thing and does something completely different. Or another example is, and maybe I shouldn't be saying this because I'm also a proponent of the language, but I've done a lot of Scala development. Like in the last 10 years ago, I think I was actually working for a company that did Scala, and it's great. It's a great language, and it allows you to be super expressive because you have this idea of a context. You have certain things defined in the context. So when you call your function, you don't have to pass everything as parameters. It kind of pulls them from the context. It's called implicits. And this is also, that's a very good name because it also shows the dilemma, because now things are not explicit anymore. Whatever value is passed in, it's just inferred based on the type. So it becomes very implicit. So this can feel like magic as well. And this can be hard to maintain and hard to understand.
Yeah, I was going to say that you covered a lot of ground there, and thinking about even like an ORM being maybe a little too magical in some ways. And I'm curious, like what sort of can you share off the top of your head, like maybe an example of where you feel like an ORM was getting in the way for some reason or making it more difficult? Because I come from a place of, I do like working within frameworks because I'm like, it's making a lot of decisions I don't have to worry about. So I can just ship some stuff for a web application or something. So where's that distinction for you for when it's like, maybe you're using too much of a framework or relying too much on an ORM and dropping down and just doing some more raw SQL or something?
So it's actually been a while since I've used them. So what were the gripes I had with them? I think one thing was that at some point it stops being intuitive. I think we had a foreign key relationship and we wanted to select based on a property of the linked table, and you couldn't use the sort of the built-in notation. Then you had to sort of define your own custom queries in your mapping file. And it's not that it's not possible. Actually, it's a very strong framework, right? It makes the easy things easy, but it does have this flexibility. I just feel it makes things much harder to maintain, really, because now suddenly you have to deal with these sort of intricate details of your mapper, and then sometimes it won't it will lead to unexpected results as well, right? So a small change in your code might be a huge change in the generated SQL, or it might have a huge performance impact, right? So maybe you need a collection of things. And if I remember correctly, so the standard approach there was to get IDs first, and then it will iterate over the IDs and get the objects one by one. So you need to write your custom accumulating queries. I hope I'm not totally lying here. I think these are things I remember. And then the session, or this whole session concept, where you sort of, or you have this intricate relationship between, let's say you're building a web application, you start your request, and now at some point you have to start your transaction, say, right, your database session. And now if you do it explicitly, you have to be very careful, because if you close it too early, you actually can't access data anymore if it needs to be lazily loaded, right? So most of it is lazy. You get something, and then only if you display the properties it will actually lazily load it, which is not super intuitive, right? It looks like you have the data right there, right? You got your collection in memory. It's just empty, and it will lazily be filled once you access it. So now maybe you've already closed the database connection, and then you get an exception. So what do? You're going to leave the connection open for, or you can attach a connection to the length of the request processing. You do it in some sort of request filter, middleware. Now there's more magic. You can inject things around. It just becomes harder to maintain.
I just haven't heard that kind of taken a while. And so I'm kind of wrapping my head around it a little bit, because, as I said, I do work
Can I ask you? I think you're a Ruby guy, right? And I remember many years back, Ruby on Rails and Active Record and sort of scaffolding. That's magic as well, I think, right? I'm not really big on Ruby on Rails. I think I'd probably struggle with that a bit in terms of long-term maintainability. What do you think about that?
Hey folks, it's me, Robbie. I want you to take a moment and close your eyes. Now picture your code and your applications as a symphony. Now to keep that symphony playing smoothly, you need an orchestra of tools. That's where our podcast sponsor, AppSignal, takes center stage. They combine the elegance of error tracking, the precision of performance monitoring, and the harmony of logging into one symphonic suite. Whether you're composing with Ruby, jamming with Elixir, orchestrating with Node.js, or harmonizing with Python, or maybe even a little bit of flourish of JavaScript, AppSignal's got the sheet music for you. And here's the crescendo. Plans start at just $23 US a month. That's got to be music to your budget's ears. Plus, they're certified ISO 27001, and they dance the GDPR and HIPAA compliance beats. So don't miss a beat, my friends. Head on over to appsignal.com and tell them that your good friend Robbie from Maintainable sent you. Now, open your eyes and let the symphony of smooth coding begin. Let's get back to our show. There's a certain aspect, like prior to me getting introduced to, say, Ruby or Ruby on Rails, I came from a space where I was writing a lot of SQL and doing a lot of, creating a lot of basically stored procedures or functions and rules within the database itself. So I'm curious where you might land on that kind of spectrum of having that be maybe something that you maintain in the database, or as much as you can in the database using Postgres or whatever, or do a bunch of things in there and have triggers and things happen, and maintain a lot of your business logic about how things should happen and how things should cascade as you're interacting with the database, or fetch some data out of there, and then having your raw SQL and say your Perl or Python or PHP, which is the stuff that I used to work with prior to Ruby on Rails. And for me, it was like every project felt like such a different experience of diving into as someone that dives into an existing software projects. It was like, okay, well, what was the flavor of how this previous developers worked on this? And then I have to then understand that. And then when I got introduced to Ruby on Rails, it was like, we're going to, yes, provide a bunch of magic, but also provide just some opinions about how this might work. And if you stay within the lane, you can get things done quicker, potentially, for a lot of common CRUD type applications. So it was just really amazing for that. But I also am someone that works on older Rails applications, and there sometimes where it feels like we're making changes to accommodate the evolution of the framework, not necessarily the evolution of the business needs for the organization. And there's this interesting kind of I would imagine that you would get away from that with a non-framework either, as languages evolve. But and how do you kind of iterate on that and on the application versus just trying to keep up with the latest version of things in the framework or the.
So I think one point you touched upon there is conventions, right? I think something like Rails, and I'm doing air quotes here, magic, but also it brings some convention. It says, hey, put your controllers here, and this is your directory store, and this of course helps. This is great, and I'm totally not against that. And maybe so to get away a bit from the specific frameworks. Also, I really haven't used Hibernate, for example, in a long time. I hope it wasn't totally, maybe it has also evolved. Maybe things work differently there now. But what's important, I think, as a developer is this not being scared to change things and being feeling in control of your code base, right? Like feeling, if I change something here, I know what's going to happen, right? So it's not it's not the feeling of magic. It's not like, oh, if I change something here, something magic is going to happen elsewhere. But this feeling of, I understand what's going on in my code base. This requires certain boundaries, right? If it becomes too big, then you have this, you change something on the left end and somewhere way down the right, suddenly something unexpected happens. Especially if it's badly modularized, and all sort of boiling down to a few database tables maybe. And the other thing is that the amount of components that you just don't grok, that somebody may brought in or that are very encapsulate a lot of complexity in some seemingly simple interface. So these, I think then it just becomes tricky, right? Because you don't really understand what's going on in this component, and that of course makes it harder to change things.
I can appreciate that. One of the topics that I was looking forward to speaking with you about is event-driven architecture. So for those listening, and somewhat myself, who might not be familiar with this, could you provide us with a bit of a basic overview of what event-driven architecture is and where it might best be applied?
So I have a specific take, I think, on how to approach this, right? Because most people, when they think of event-driven architecture, the first thing that comes to mind is asynchronicity, right? Sending messages over Kafka or some messages, which is an important part of it. But I think the even more interesting aspect is the way of the semantics of the communication, say, and then following from that also the patterns of communication. So when we talk about events, of course, usually we talk about asynchronous messages, but these messages have a certain semantic. They are facts, right? So I communicate by stating facts. And this is very different to what we are used to when we do web programming or when we do imperative programming, right? We don't just state facts. We call methods. We call functions. We make HTTP calls, right? So we say, do this. We provide instructions, right? We use commands. We command the computer to do certain things. So this is the kind of the mind-boggling thing in it as well. So you have to kind of reverse your thinking, and you don't say book this, but you say this order has been placed. Right? As a fact, I accepted this from the customer. He's placed an order, so this is the fact. The fact is this order has been placed. And then I emit this fact, and then others react on this. And now, well, this actually is a nice connection to what we just talked about earlier when I said in a big system, maybe you do something on the left and you don't know what happens on the right. I think a lot of people, especially if they're not very experienced with it, this is a fear they have about event-driven systems, that they say, oh, wait, how does this work? You just emit an event and then you hope that somebody picks it up. So the whole idea of event-driven architecture is based on promises, you might say, right? You have a very clear, at design time, you have a very clear idea of who's responsible for what. And you emit an event, and then somebody makes a promise to pick it up. So it's not so much like you writing a message to some WhatsApp group and hoping somebody will act on it. Right? Like, let's say, when you're hungry, right? And say you post to your WhatsApp group, hey, the event is I am hungry, I would like a pizza. And then you wouldn't rely on any one of your contacts, right, to bring a pizza to you. But that's very different in a restaurant setting, right? When you're sitting at the table and say, I'd like a pizza, then a waiter will pick up the order, and they have like a tab bar in the kitchen and he'll post the order there. And again, it's not like emitting the event, oh, this order has been placed. There's some contract in place prior, right? So the cook will pick it up and will deliver the pizza. So this is an important aspect of it as well. Did we get there? Oh yeah, event-driven architecture. So event-driven architecture is about emitting events. It's about promises. It's about, rather than explicitly calling somebody or calling a service and ordering the service to do so, or to do something, or asking the service to do something, it's about reversing this and saying, this happened. And I know when this happens, there's somebody else who promised to act on this. So I know this happened, this order has been placed. And I know there's going to be an inventory service that's going to pick this up and check if we can actually deliver this. And there's a payment service that will make sure we get money for it. Yeah, and I believe it's a super powerful architecture, right? Especially now when we build, not for every system. If you have a small monolithic system, that's fine as well for many use cases. But once you move into you want to scale out also team-wise, you want to have different teams working on different services, you work with microservices. then how do these services communicate, right? So, and one approach, of course, is the command approach, or or synchronous calls, or you use HTTP or gRPC, call the other services, but that creates a very strong temporal coupling, right? The service has to be there and available at the moment you call it. And this is one of the advantages you get with event-driven architecture, that at runtime, the dependencies are very slim, right? You emit an event and it's going to be picked up eventually, hopefully, but it doesn't really concern you if this other service is running at this very moment. And then it's very easy to scale, right? It's very easy to have a number of services, a number of instances maybe of the same service picking up events and working on them in parallel and things like that.
While we're preparing for our conversation, you said choreography beats orchestration almost always. What do you mean by this?
Oh, did I say that? Yeah. So we look at these. If we look at single services, it's easy enough, right? There's a service that gets something in, gets some user interaction in maybe, or gets an event from another service, does something, changes its internal state, emits some event. But what we really want are processes or business flows across multiple services, right? So how do we make sure this happens, right? If to go back to it, it's like a hello world example for event-driven, maybe where you have an order, and to fulfill this order, the item has to be available in stock and the payment has to be made. So there's already a small business process there, right? So you need to check, or you need to get the payment somehow, get some payment confirmation, check if the item is in stock. And both of these have to be successful in order to do this. So how do you define this process? In choreography, this happens at design time. Well, in both cases, of course, there's some design. You have to sort of manifest the process somehow. In choreography, you rely on your design. You say, I designed the service in such a way that it will pick up this event and it will emit an event. And there's no central point of knowledge that knows the whole process at runtime. In orchestration, you say, okay, I'm going to have some sort of coordinator. There's going to be one element in my design that has an understanding of the whole process. This can be an individual service where you say, okay, I have the central order service, and this order service calls out to the other service that knows what needs to be done to fulfill the order. Or, of course, this can be a generic component, like a workflow engine, or sometimes these are called differently now. A workflow engine, I think, sounds a bit old school, enterprisey. So now companies offering this call it persistent execution engine or microservice orchestration engine or things like this. So when you come from a monolithic world and you think of these workflows, then this might seem easier, at least on the surface, right? Because you can basically use your old workflows that used to work in a monolithic world with bigger systems and kind of transfer them to the microservices world. So why do I say choreography beats orchestration almost always? Because the things you want to achieve by breaking up your system into services and having autonomous teams working on it are strong encapsulation, right? And you want to have a team that works. I mentioned these strong boundaries for maintainability earlier. So as soon as you have this orchestration level, you reintroduce a monolithic aspect, if you will. Now, suddenly you have this other layer where you say, okay, I have this cross-domain layer that needs to be maintained somehow. And now my business logic, so a lot of business logic is going to be in the individual services. But now suddenly some of the logic is in the orchestration layer as well, right? So kind of how does this, so what goes where? If something goes wrong, is this an error that should be handled in the orchestration layer, or should it be handled in the individual service? So I have to look at, also then at runtime, if something goes wrong at operations time, right? And there's an alert. Now, who's in charge here? The person responsible of the service, because they shouldn't have issued this error, they shouldn't have caused this error, or the orchestration error because it should be able to handle this error. So suddenly it becomes more blurry. And plus, these orchestration tools are complex as well. They're very complex technology as well because they need to scale, they need to be resilient, they need to persist their state, and so on. So you're putting in some magic, if you will, into your project because now you have this component that magically orchestrates your workflow and might be hard to understand or might be hard to sort of really get into. And one last word about it. Something that bugs me is that often the discussion about this is very, I call it folkloristic, right? People say, oh yeah, well, if you have a complex workflow, so what's your heuristic, right? How do you decide if you use choreography or orchestration? And a lot of people will say, especially people who sell orchestration tools, well, if your workflow becomes really complex, then you might want to look into orchestration because it's hard to kind of keep track of what's going on then with choreography. And I find that misleading because this assumes the workflow is a given, right? It's like you have this business process and to implement it, exactly like this in a workflow is the only way of doing it, right? But as architects, we're used to challenging requirements, right? So customers your client comes with some requirements like, hey, I need this to happen in a single transaction, or I need this to whatever. And then you say, hey, okay, is this really, like, what do you really need, right? What are the consistency guarantees you really need? What is timing behavior that you really need? The response times that you really need? What is just tradition, or what is how you think it works? And what is an actual business requirement? And I think when it comes to workflows, we have to take the same approach, right? And say, okay, this is your workflow now, but maybe we can break this down in, some people call this micro workflows, right? So maybe you have this whole order process. Where does it start? Where does it end, right? You could say, okay, the order process, it ends when the package is handed over to a delivery service. But it can still, maybe it can't be delivered. Maybe the workflow even goes on, right? Or the customer can return the package for 2 weeks or whatever. In most companies, that would be a new workflow, though, right? So there's always, this is a design decision. Where does the old workflow end? Where does a new workflow begin? And I think we can make workflows more compact and say, okay, we have an event, we do something, there's maybe even some orchestration there, talking to a third-party system, talking to a legacy system, whatever, but then we end with an event again, and this is where this workflow ends, and then we start a new one. So we, instead of solving a complex problem, right, saying, hey, we have a complex workflow, so we need a complex solution for this, like an orchestration tool, let's decomplex it, right? Let's break it down, and rather than sticking within this complexity, let's try to make it less complex and have simple parts that we can then sort of plug together.
I'm curious about this sort of approach to software development. When you're bringing, like, do you feel like this helps people get onboarded into an organization's services and like understanding how the big picture works? Or do you find that it makes it easier for developers to join a team and be like, all right, you're going to work this area and this is what we're promising to be responsible for, so we can kind of focus over here. An order came in and we're responsible when we notice that this come through the events. This is our scope. And then, but do you need to know what else is happening elsewhere? Like, how do you think about that from just like an onboarding experience?
That's a very good question, right? Because this can be misleading as well. It can lead to a thinking of, you want dumb developers that don't understand the whole, that only know like the little bit they are working on, and they don't even understand what they're contributing to. So I think it's somewhere in between, right? So like, I think it's ideally, maybe it's great if you don't have to. Right, it's fine if you want to understand the whole, and maybe you should have a basic understanding of the whole. What's the overall business process you're contributing to? You probably want to know what does the company actually do? Right? How does whatever you do actually contribute to the business value? But when it comes to coding and improving your service and sort of getting really deep, it's also very liberating if you know, hey, this is my contract, these are the events I need to produce, this is what's coming in, and I can completely focus on this. And as long as I don't break the contract, I can do whatever I want. I don't have to care about whatever technology they use there, or have to care about, some weird side effects that things might be having that I'm doing, because we have clear boundaries and I can really focus on, or let's say I have this, it's a bit like T-shaped, right? So I have this on this horizontal level, I have an understanding of the overall system because I'm interested in this, and I need a bit of context to do my job really well. But then I have this vertical area, I say, okay, but this is my area, this is my service, and I own this is my product. We have a product as a company that generates the business value, and this is my product within this product, right? This is my API, these are my event topics. This is a product that I provide to my fellow teams that use my API as a product. There can be a lot of fulfillment, I think, in this as well, of building a great internal product within the boundaries of it.
We'll be back with our interview with Lutz in just a moment. Hi, it's me, Robbie. I'm the problem. It's me. I want to take a quick moment and say thank you, listener. Thank you so much. I'm thanking you because I know that you've already headed over to Apple Podcasts, or maybe you went over to Spotify and you gave us a rating. You dropped in a few sentences and said, I really enjoyed that podcast episode with Lutz Hühnken, or I enjoy Robbie's interviewing style, or Robbie's a mediocre podcast host. 2 stars. Whatever it is, just go do it. It would mean the world if you haven't done it yet, to please do it. Also, who do you think I should have on the podcast in the near future? You have a guest recommendation? Maybe yourself? Maybe someone you used to work with? Shoot me an email to Robbie with a Y at maintainable.fm and state your case. And now let's get back to our interview with Lutz Hühnken. And just for my own curiosity here as well, is like, so in this event-driven architecture approach, and let's say there's a couple things that are going to happen. There's initial events created, and then some other services like picks it up, notices that type of event, like, oh, I'm supposed to do something. Is it then typical then that service then will also then trigger an event that makes it known for other, I'm saying down the pipeline, but I don't want to, but that almost makes it sound like it's always going to be a linear thing when be able to like have that stuff happen maybe a little bit more asynchronously as well. So does it matter? Like, does an event pops into the system, one thing, but don't act on it until you see that there's another event by another service because it's not ready for your other service? Like if there's a third service that needs both of those first two ones to do something?
Yeah, absolutely. It's not, and you say down the pipe, and a lot of people say downstream, right? There's like a stream of events or multiple streams of events and other services pick it up. And yeah, if you look at an overall process, that is exactly what happens. There's this, I think in functional programming, people say, well, because if you do pure functional programming, you don't have any effects, so you can't interact with the outside world. Right? So they talk about imperative shell, functional core. And an event-driven maybe often we have a similar experience where we say we have a sort of a request-based shell. HTTP request comes in. We deliver some response, which is just acknowledgement that we received the request. Right? Then we emit an event, and then other services react on this. So we create a stream of, over time, we create a stream of events. And this can be transformed, right? Some other service picks up an event, generates another event. It's very much like stream processing, really. So the stream can be split, or different services can pick up the stream, can be joined, it can be transformed, whatever things can happen. And at some point, of course, it goes back, and then you get some notification that probably some email or some message on your phone that your order is actually going to be delivered or whatever. So yeah, absolutely. So it's all triggered by events, and then usually you also emit an event and then the end. But there can be side effects, of course, as well. You might also persist something in the database or call out to some other external service. Or
I wanted to ask you about your new title, Head of Engineering Excellence, which is a new one for me. Could you walk us through the thinking behind what are you experimenting with over there at Upvest?
Yeah, absolutely. We're touching a slightly different area than that, right? So let's move away from the architecture to sort of the meta level. How do we organize architecture in a company? How do we make sure, like if we believe architecture is important, so maybe that's the starting point, right? So I believe that software development, successful software development I believe in systems thinking, right? I think it's a system that has many components that need to sort of interact. Or somebody once said all these different things you do, if you do DevOps and Agile and maybe event-driven architecture. Or let's say you have the appropriate architecture for your system and you have the appropriate process and the appropriate maybe operations model. These things don't add up. They multiply each other. So if you do get one completely wrong and it's zero, then nothing works, right? Because then the multiplier is zero and it kind of even nulls out the others as well. Or I think I've often used the car example, which is also, I picked it up somewhere. It's not my idea, but what makes the car go from A to B? Is it the wheels or the steering wheel or the engine? Or it's everything, right? Everything needs to work. If one component in your car is broken, the car doesn't work. So an architecture in the overall world of software development, I think architecture plays an important role because the architecture we choose limits our ability to define the organization as well, right? If we have a typical example, if we have one monolithic application scaling out the development to many teams, we might still do this, but we will probably not see the effects we want to see, right? We will probably not be able to scale linearly because now there's a lot of coordination necessary. We're going to have lockstep releases between all the teams. So as we grow to more teams, it's probably diminishing returns, right? So if you have 5 teams working on a monolith and you double the number of teams, it will probably not double the productivity or is it the productivity? Well, let's say the outcomes there. While hopefully in an architecture that allows all the teams to work in parallel within the contracts they've made with other teams, within the product, hopefully that works much better. So architecture is super important. So we need to think about how do we make sure we have the right architecture, right? And have the right sort of flight level for this. Because I totally believe in autonomous teams as well, and teams that make their own decisions, right? It's super important that the decisions are made where the work is being done. I worked as a developer, and I worked in environments where they had like an architect, right? Somebody was the designated architect and had the great idea of how the system was going to be built. And as a developer, it felt like you couldn't make your own decisions. Like you had to live with whatever the architect came up with. with. And some of these decisions were not good or caused a lot of grunt work, and that was very demotivating. And the people who do the work know how the things actually, they own the stuff. The team should own their product. And so if they're responsible for what they do, they also need to make their own decisions. So it's not about taking decisions away from the team. We definitely want to leave the decisions with the coders. But we want to create a sense of alignment between the teams. Right? We don't want every team to go every way. And we want to make sure that we bring in this broader perspective. Because every team is set up to have a great insight into their work, but I think this touches a bit on the question we had earlier. Right? How far do you understand the whole? Like, not every team can see everything at every time. I think this would just be too demanding. So you have the position you're in, and you look out and you see this where you want to get to, but that's like the local maximum, right? And so you need maybe some people in the company that just kind of step up to a higher level and say, okay, we have this other perspective. We see the local maximums of all the teams, so we can kind of identify the global maximum we want to get to. And this is something I've been thinking about a lot, and I've worked on a lot and tried different things in the past, because it's it's an interesting topic to find the right line there, to provide guidance. A catchphrase we had in a company was management by principles and guidelines, right? So we don't manage the people, right? We're not, they don't report to us. But we had a little group of architects, and what we did was a lateral management, right? So we would rely on people to believe us and to trust us. And when we told them, hey, let's do it this way, and if we rely on this, that's going to be great. So we had to be really good in communicating the principles there, and had to do a lot of work around making sense, explaining the why, and getting people interested in it as well, which worked okay, because also I think it's important to realize that developers are not always hostile and always sort of not open to ideas from the outside, or often they're actually happy if there's some guide and some guidelines. It's a bit like the conventions, right? I mean, you have a lot of things to worry about. You need to deliver this feature, and maybe you don't want to concern yourself with which Kafka client library to use in the project, and you're super happy if there's a convention in the company and all the other teams are using this. There are a lot of people who know this if I run into issues and so on. So sometimes it's also picked up very positively. So coming back to the new role. So at Upvest, so far, it wasn't really a topic. We had a very sort of technically strong founder team, right? I think so. There was this initial architecture that served us very well. Then we grew to now, let's say 75 or so people in engineering. And this was the way this happened and the pace this happened. This still worked out pretty well without some explicit function across the product teams for architecture and engineering productivity and so on. And now we're kind of preparing for another phase of growth, right? We're looking towards the next funding round, getting on more people, growing the organization. And so now we want to anticipate this a bit, right? We want to say, how do we make sure that we keep the standard? How can we maybe, and this touches all aspects of software development as well, right? Sort of how good are we? Sort of how do we measure our productivity? Can we improve on this? Which are the actual principles behind our architecture? Are they still up to date? Do we need to modify this? Have we codified them well? Is it easy for new joiners to understand them? Do they make sense? Can we improve the onboarding experience here so that people actually understand what they're dealing with? So we're still exploring this. I only really started this job like 3 weeks ago. It's engineering excellence as a whole. So the architecture bit is a part of it, right? So this is probably going to be my focus in the beginning, identifying maybe some possible bottlenecks for the scalability of our systems and addressing that. But we want to go beyond that, definitely. We want to make sure that we have great engineering experience. We're going to work closely also with our developer experience team, or as we call it, engineering enablement. We want to look at processes. We want to look at the way we do testing, if we can improve this. As I said, trainings, onboarding, mastery is also what I like to talk about. A lot of people remember this from, what was it, Pink? The aspects of intrinsic motivation. I think it's purpose, autonomy, and mastery. And we as a company definitely do a great job when it comes to purpose and autonomy. We're also probably doing an okay job when it comes to mastery. But I think it's super important that in software development that we provide this growth path for everyone as well, that people can learn and can get better at their job and can explore new areas of software engineering as well.
Something I've been thinking a lot about lately part of it's because of just the economics of the last few years. There's a lot of layoffs in our industry. I've been wondering, so I'm kind of curious if you're at a point in your organization where your role is changing because it's also like your organization is going to likely go through another scaling up with more people. Do you often think about, do you have many conversations or think about like, but we may not continue to scale the size. We may actually be smaller one day. So how do we make architectural decisions that allow us to not rely on always growing the number, a headcount of engineers, but ideal feature might be a smaller engineering team than we need for the next 2 or 3 years. How do you think about that? Or is like, well, that's a problem. We'll just figure it out when we get to it.
No, absolutely. That's a great question. And I also don't believe in sort of ever-growing engineering organizations. And we don't want to build a 1,000-people organization. And in some companies, I honestly have no idea what everybody's doing there. Like if you have 10,000 engineers, what do they actually build? But then, I mean, if the companies shut down at some point, or we say, okay, we just stop developing, okay, then we definitely don't need this, right? But in the past, we had a period now of basically stable headcount, right? In the sort of fintech winter. But then there's still things to do, right? Then it's about improving processes, doing more with less, right? Making sure that we are always in the position where we can continue to deliver. So it has these two aspects of anticipation in terms of the way you build things, even if you're not growing as an organization, still want to have maybe the people who have a lookout that you don't take too many shortcuts and don't accumulate too many tech debt, right? Because also something I saw in some talk, somebody started it with, we don't just need to deliver, we need to deliver and then deliver faster. Sorry, I forgot the exact quote, but it's not just about delivering now. Of course, we need to deliver the feature, but we need to deliver now, but we're going to continue to deliver, right? And ideally, we even accelerate, right? As we grow as a customer, even if we don't grow as a company, as our customer base grows, they're going to be requesting more features and more changes ever a shorter time period. So we need to be in a position to be able to do this. And then when it comes to also, but then in terms of scaling the company, you talked about, okay, maybe there's this point where you say, okay, it's actually not going to happen. We're not going to grow that to that size. In terms of our system, the scalability of our system, maybe we're in a somewhat special position there. What we're building is investment infrastructure, right? So we're going to be used, or we are being used by banks, and it's a sort of a low margin business. Our whole business model only works at scale. Like if we don't have millions of accounts, then we will have to shut it down because our system doesn't work and is not financially sustainable with 100,000 end users, right, being onboarded on it. So it's a bit of a bet, right? We believe in our business model and we believe in the demand, but we don't have to cater, I think, for a case where we say, okay, we're going to find these 10 customers and we're going to operate on this level, because for like a financial backbone, that just doesn't make sense, right? Yeah.
That's useful context, I think, for me to think about. I think it depends on, there are some software projects that very much rely on there be a high throughput of users, customers to keep the thing operating. But also organizations start small, they grow big. And then I just hear a lot of people talk about like, well, we got to keep scaling things because our engineering team, I was hired, I'm just kind of like, someone was hired into a team when there was rapid growth. And so they're making decisions or thinking like, that's the way it's always going to be here. But that doesn't always end up how software teams long-term always evolve. They might get smaller again at one point, and then now there's maybe a lot more stuff all those little microservices might need to be collected by multiple teams, some of the responsibility there. So how do you just make that simpler for today and then also for tomorrow to keep delivering? I think it depends on the context of your organization.
You said keep delivering, and I think that's the crucial point there. If you don't deliver and you just spend, you focus on creating the perfect architecture that will scale indefinitely, but you spend so much time and energy on this that you never get to deliver, that also doesn't work, right? So you have to find the right balance there, of course.
Hey folks, it's me, Robbie. I just want to take a quick moment to plug my own company, Planet Argon. We're a software development consultancy. We help organizations with existing legacy applications make them better and more maintainable. We specialize in technologies like Ruby on Rails. Did I mention Ruby on Rails? Laravel, React, some other stuff as well. If you're curious about getting some assistance with your project, or maybe you know of a project that needs some support, maybe some long-term support development, but they don't necessarily need full-time engineers working on the project all the time, send them our way, planetargon.com. We'll see if we can help them out. Back to our show. So a couple of quick last questions for you. You mentioned technical debt. Do you use that term very often in your day-to-day work, or how would you define it today? And do you feel like it's evolved, say, from 20 years ago in your head?
That makes me think about it. I do use it, but without giving it too much thought. I think this is actually a discussion I haven't really been following. I think I'm kind of aware that people don't like the approach, or I have one colleague that says, oh, we shouldn't sort of put it on the tech people. It's actually business debt. It's like it's their debt as much as ours. I actually like this kind of metaphor of debt, right? That because it can also be something you do very willingly, right? That you say, oh, at this point, yeah, I'm going to take up this loan because I need to do something at this point in time, and then I'm just going to pay it back later, right? So tech debt. I think this is the way I use it, right? It's because it's you build up debt because you made an investment in a way, right? So it's not, to me, it's not about this is bad code and this is good code. So the bad code is tech debt. It's more like sometimes we take shortcuts. Sometimes we know this, and thinking of this in terms of that also lets us think about payback, right, and interest rates and so on, right. So if we have a lot of tech debt, that means we're probably also paying some interest on this, and we probably have to pay it back sometime. So this is kind of the part of the metaphor I like.
So I'm curious if you can offer any advice to those listening who might find themselves on a team right now where there's a large list of things to do, technical debt issues, and they've might have asked, I'm air quoting, the product people or whoever's in charge of like the backlog or those lists and stuff like that, and they don't feel like they've said, hey, I would love to spend some time improving this area of the code base to make my life easier, but they've heard maybe not right now, maybe a few too many times, and so they've stopped asking. What would you recommend that they do in that type of situation?
That sounds a bit dysfunctional to me, right? There seems to be some issues also in the way a lack of collaboration maybe between the sort of more producty side and the more tech side. The product side needs to understand this, that we sometimes build up debt and need to repay this. Or also what we try to do, and I think I would also recommend this, I think a lot of organizations do this, is that we try to keep a look on how we call this investment distribution, I think, in a way that we sort of, how do we spend our time? As a developer, we try to classify our tickets, right, our tasks, and say, oh, this is developing a new feature, but this is not. This is just keeping the lights on, right? This is just some bug fixing I need to do, or updating some dependencies and so on. And this is work that we do for ourselves. This is productivity enhancement work, and there's the fourth category that I just forgot, but you get the gist of it, right? So, and then there's no strict rule that you say, okay, like 20% needs to be on productivity enhancements. But if there's zero work on, let's say, on refactoring and improving the code base and on working on your own tooling, that's a smell. Right? Then probably it's going to hit you later on. If it's 100% new feature development, then probably at some point later in time, it's going to be 100% refactoring and repaying tech and that, right? If it's 10% feature development and 90% keeping the lights on, then something went. Then maybe it's time to sort of step on the brakes and say, okay, what are we doing here? This is something. Do we need a bigger refactoring? Do we need to pause the things? How do we get back into a more productive mode? So definitely have an eye on this and develop an understanding of a healthy distribution for your service.
I think that's some really good advice for folks to consider. Is there a non-software, non-technical book that you find yourself recommending to peers that you work with?
No, maybe something classical. Maybe read some philosophy book, or really read what's it called, The Open Society and Its Enemies, or so, by Karl Popper. Maybe it's just me, but we always tend to read sort of the latest and newest, and often not even books, but just blog posts and things. And sometimes it's good to sort of go back to some fundamentals. And then there are sort of seminal books outside of computer science that are really interesting and that shaped a lot of things, a lot of ways of thinking, how we think about societies and the dangers of that democracies might face and so on. So I think Open Society is an interesting book. Yeah, I must admit, though, it's been a while since I read it, but I don't know why this one just comes to mind. Something subliminal processes there that just brought it up. Or some Stoic philosophy, I think, is always good.
Awesome. Yeah, I will definitely include, I'll look that book up and I'll include it in the show notes for listeners. I always like to hear what they find interesting to read when they're not just looking at their computer or books to help them work on their computer. And where can listeners best follow your thoughts and ruminations about software engineering online?
Oh, yeah, I keep a blog, but it's a blog very sporadically. So, and if I do, I'm posting it everywhere. Once I actually finished a blog post, I'm posting it on Reddit and LinkedIn and Mastodon and so on. I guess following me on LinkedIn is the best way, because also there sometimes I write small pieces. And if I write a proper blog post or create some other content or hold a talk somewhere, I will always post it there as well. So people can follow me there and be up to date.
Wonderful. Well, it's been such a delight having you join us on Maintainable, Lutz. Thank you so much for stopping by to talk shop with us.
My pleasure. Thanks for having me.